In this video, I will show you how to do the Multinomial Probit and Logit models, the Conditional Logic model, and the Mixed Logic model. And I have three different programs for us to take a look at in Stata. So this is the first set of program, how to do the Multinomial Probit and Logit models. And then I have already executed the program, which you see right here on the right hand side, and you can follow along with the results. So we're going to consider a data set on fishing, and I'm reading in the data set, and I'm going to open the data set so we take a look at it. Here's how the data looks like. It's in the wide format, which means each row is for one individual. So mode would be our dependent variable, okay? And we can see that the first person has picked the charter mode. So we have four different choices: beach, pier, private, and charter. So the first person has picked charter, the second one charter, the third one private, the fourth one pier, and so on. And we have one line per each individual. And the other variable that we will consider from here is income. That's going to be our independent variable. And notice that this variable is alternative invariant. Therefore, no matter what alternative an individual picks, they only have one income. So these are the two variables that we will consider in this model. So let's go ahead and define the variables. Here for global, for my y variable, I will have mode, and for the x variables, I will only have income, one variable. If you have more independent variables, you can just put space and write them out here. Now, the one thing to notice about this example is that we have four categories denoted by 1, 2, 3, and 4. These are the different fishing options. So you need to pay attention for the rest of the program. If you have different number of options than 4, you will have to make slight modifications, and I will show you where in the program. And the rest of the program should work with your data if you just put here your y variable and then your x variable. So I will describe and summarize the y and the x. And here for the y, the fishing mode is the dependent variable, and income is the independent variable, monthly income in $1,000. For summary, here is the summaries. Again, for the mode, that number is meaningless because choices 1, 2, 3, and 4 are just different categories and the numbers don't mean anything. So don't report this number in tables. Here's the correct way to summarize a multinomial variable, and these are the percent frequencies. You could have the frequencies. We have 1,182 observations in the data set, and these are the percent frequencies. So notice that this charter option has the highest percent frequency in the data. 38% have picked that option. So it would be good to report this table in your paper, in your analysis, when summarizing the dependent variable. So the next thing is to look at the Multinomial Logit model. Okay, so the command in Stata is mlogit, and then you give it the name of the y variable, for us is mode, and then put all your x variables behind. And if you don't specify which is the base outcome, Stata would consider that as the most frequent category. So here you see how charter does not have coefficients because that was picked to be the base category. So these coefficients are assumed to equal to 0. And now we have the number of the number of sets of coefficients is 3, which is the number of choices or alternatives minus 1. Okay, so here the way to interpret this is that if income increases, the beach option is well, actually that's not significant here. Okay, so This one is significant. So if income is higher, then peer is less likely in comparison to charter. And here we have that if income is higher, the private option would be more likely in comparison to charter boat. So that's how we interpret these results. No interpretation of the magnitude, only more likely and less likely. So now if you would like to specify the base outcome, which you should in your program, here we could specify the base alternative to be the second one for us. And we could either put here peer, or we could put the number 2, because Stata has two ways of recording peer. It could hold both the number and the label for that. Okay, so this is the multinomial logit model. If you have the base outcome alternative 2, notice now that peer is the base outcome here. And therefore it does not have coefficients. They're assumed to be equal to 0. So now what we can say is that in comparison to peer, the beach option is more likely if the income is higher. If the income is higher, the private option is more likely, and the charter option is also more likely. So that's how you interpret that. And notice that these coefficients here and whether it's positive or negative, they're very different from the previous model. So the next thing we can do is we can predict the marginal effects, and that is done here with the mfx command, comma, predict, and then the outcome equals 1, 2, 3, and 4. Now in your case, if you don't have 4 options or they're not labeled 1, 2, 3, and 4, you will need to change here to correspond to your numbers in your categories, these numbers from 1 through 4. But here are the marginal effects. And we have, if income increases by 1 unit, then we have that the likelihood of the beach option being selected right here would be, let's see what percent is that, very small percent, 0.0075% higher. So if income is higher by 1 unit or $1,000, then we would have that the peer option right here is 2% less likely, and so on. That's how you interpret those marginal effects. And you can go ahead now and interpret the magnitude as well. And notice that these numbers right here would have to sum up to 0. That's true for the marginal effects. So if you want to take a look at the predicted probabilities, you can predict it using these, and you name them. This is the names that I've given it, and then do comma PR for the predicted probabilities. And here are the predicted probabilities. And you can see that the means are summarized here, and they very closely correspond to the actual frequency. So we have the models are usually doing very good prediction for at the mean, on average is doing very good prediction. Now if individual observations are predicted well, that's a different story. So okay, so then next what we can do is this time we can estimate the multinomial probit model, and the command for that is mprobit instead of mlogit, and then you give it the y and the x variables. And here are the results that we have here. So again, if you don't specify a base outcome, the base outcome would be the most frequent alternative. And here we have, again, you can say more likely and less likely, but notice that these coefficient magnitudes are different than the Logit model. And that's why we cannot interpret the magnitudes, just more likely or less likely. And likewise, if you put here on the Probit model, comma, base outcome 2, this now means that the base outcome would be the second outcome, which is peer, and those coefficients would be normalized to 0. And again, if income is higher, you would say that people are going to be more likely to choose the beach option in comparison to pier, and so on. That's how you interpret those results. So for the Probit model, you can also do the marginal effects, and if the interpretation is exactly the same as the Logit model, and if you compare those marginal effects now, they are very similar to the marginal effects from the Logit model. And that's exactly the same case as we have with the binary Probit and Logit models, that the coefficients may be different, but the marginal effects would be very, very similar. And then the final thing that you can do is predict, do the predicted probabilities for the Probit model, and use the command predict. This is the variable name that you're giving it, and then outcome 1, 2, 3, and 4. These are the commands, and you can summarize them, and you can see that again, on average, the multinomial Probit model is doing a good job predicting the actual percent frequencies that comes from the sample. So this was a program on how to do the multinomial Probit and Logit models. So next, let's go ahead and talk about the Conditional Logic model. I have the program on this side, and here's the program executed. So we're reading in the data that is called conditional_fishing, and it's a little bit different structured. I'm going to open up the data editor and we're going to look at it. Now this data set is in the long format. So notice here that we have the ID, the first ID, second ID, third ID. These are the people in the sample. And it's in the long form because each person has 4 rows based on all the options. So here we just have each of the options repeated 4 times. And notice how here beach is associated also with the first option. You see, like here, this one is the second option, this one is the third option, that one is the fourth option, if you notice that. So each of these labels is associated also with the number. Okay, so this time mode, the variable here that we had before is charter, but charter is repeated 4 times because the first person picked charter. So these were the available options for them, and they picked charter. So for the second one, these were the available options. This guy picked charter too. So for the third one, these are the available options. They picked private, and so on. So these are all available options. This is what they picked. So this D variable here would be a dummy variable that is equal to 1 for the option that they picked and 0 otherwise. So notice that when the option was charter and that person picked charter, this number is 1 and it's 0 otherwise for them. And same thing for this guy. For this guy here we have that the option was private, they picked private, and therefore this is a 1 here for the third person, and everything else is equal to 0 for them, and so on. So now this would be our dependent variable in the long form, where it would have a value of 1 if they pick that option and 0 otherwise. Now we have income, which is the alternative invariant variable. So notice how like income is repeated 4 times for each person, because that income does not vary across alternatives. The person has only 1 income. And this one has the same income repeated across all options, and so on. So this will be our alternative invariant variable. The P and Q, P is, let's see, price for available alternatives, and Q is the catch rate for available alternatives. So these ones do differ, and these were the prices for each of the options, and they're listed for the prices that that individual faces, and these are the different catch rates. And so facing those prices and catch rates, the individual picked, you know, what they picked. But these would be our alternative variant independent variables. Okay, so let's see how now we're defining these variables. The dependent variable would be 0, 1 whether the alternative is picked. And so Y list would be our dependent variable. That would be D in our case, whether or not the alternative is selected. The Z list would be case-specific regressors, or that's the alternative invariant one. And the Z list would be the alternative-specific regressors. So when you modify this program, this is the variable names that you need to put in here. We also need to give it the ID variable. In my case, this is called ID. In your case, maybe called something different. You need to also give it the set of possible alternatives. In this case is the fish mode. Here is where they're all just listed 4 times for each individual, regardless of what they selected. And here I'm picking the base alternative 1 and 2 being peer and charter. I'm going to use these as the base categories. So the first thing that we can do is to describe and summarize the data. And this is what we have for description. Again, for ID, we have the person ID number, fish mode, the income, price, and catch rate. And these are the summary variables here. So ID doesn't make sense. The fish mode cannot be summarized because it's labels. D, that variable, why is it 0.5 here? Notice that we have 4 alternatives, right? And exactly one of these 4 is equal to 1, depending which one the person picked, and the rest are equal to 0. Therefore, that's why this is 0.25, because a person can pick only 1 out of 4 options. And then we have the income and price and catch rate summarized here. So how to do conditional logic model? If you have base outcome selected as the base alternative 1, we will do the ASC logit. And then you put the Y list is the dependent variable. Then you put the Z list, which is the alternative specific regressors here. For case, you put the ID that you have. This is the ID for the person. For the alternatives, you give it the possible alternatives, which in our case is the fish mode. For case variables, you need to give it the X list, the case-specific regressors that don't vary with the alternatives. And then the last thing you put is base alternative, and I'm going to give it here either a 1 or a 2. That's the difference between these two models. And this way we could have the conditional logic model estimated 2 different ways. Okay, so here are the results with the base alternative equal 1. So notice one thing here. If you have a alternative specific regressor, notice that there is only one set of coefficients here. But if you have an alternative invariant variable like income, notice that you will have as many coefficients -1 as there are alternatives -1 here. And so again, you would interpret these coefficients here the same as you would in the multinomial logic model. So you would say here, if income increases, this option of beach is more likely. The option of charter is also more likely, and the option of private is also more likely in comparison to peer. And the coefficients that are here, you would interpret that if price of an option increases, they're less likely to pick that option, and if the catch rate increases, they're more likely to pick that option. So you can also estimate this model by using a different base alternative. So one thing that changes here, we have peer, the first one, as the base alternative, and now we have charter as the base alternative. Okay, and so here is the peer and the charter as the base alternative. And so now that charter is base alternative, we would have those coefficients normalized to 0. Notice that these coefficients are exactly the same as before, but the coefficients here completely change. Not only that, but the sign changes. because now we're interpreting them, how much they're likely, how much this outcome is likely in comparison to base charter. So that's why they change completely. So same interpretation as before. Now you can also estimate the marginal effects, and this is where it gets really complicated. So you use the Stat MFX for the marginal effects, and then you put variable list, and then you put the X list and the Z list because you want the marginal effects for those. So now notice that we have marginal effects for each of the alternatives, and you also have marginal effects on the probability of each choices. So that's why it's getting a big table. So here for the first one is the probability on the choice being beach. That's the choice that is being selected. So here income doesn't have a significant effect, but you can say that let's see, if the price for beach increases, then the probability of beach being selected is less likely. And if the price of the other options increase, the probability of beach being selected is more likely. So why is that? Well, if it's more expensive for a certain option, then you're less likely to demand this option, more likely to demand others. Likewise with the catch rate, if the catch rate for this option increases, then you're exactly 1.7% more likely to select beach option, and so much less likely to select the other option here. And the same interpretation for all the rest of the marginal effects. So notice now that this one has the negative coefficient on its own price. So you can take a look at the example where I have summarized all these. Okay, and the last thing to do is to calculate the predicted probabilities, and we can do this with the predict probabilities, and then you put comma PR. This is what I called it, and then summarize them, and then compare them to the actual Y list. And so you can see that on average we got the 0.25, and it's exactly the 0.25 that comes from the empirical frequency. So the last thing that we can do is we can generate a multinomial Logit model using the conditional Logit model if we just use the X variables and we don't give it the Z list. So notice that after Y list, I don't have the Z list here. So if you don't give it any variables that vary with the alternative, we're going to have exactly the multinomial Logit model. And if you look at the results here, and if you go to the previous slide, to the previous program that we had on the multinomial Logit model, we would have exactly the same results here. So you could get the multinomial Logit would be a specific case of the conditional Logit model when we don't have variables that vary with the alternatives. Okay, so this was about the conditional Logit model. So the last thing to do is to look at the program for the mixed Logit model, and I have the program open here as well as the program executed. So I'm going to look at the data again. It's the same phishing data, but it's a little bit different. We have the data in the long format, but some of the options are deleted. Notice that now we only have 3 options per person. So beach, pier, and private. The charter boat is not here. Don't ask me why. That's how the data in the example came. Not like it has to be the case, but in this case we would have only 3 options, 3 alternatives. Okay, so our dependent variable would be D, and I already talked about that from the previous program. So these are fish mode as the possible alternatives, and that person picked private, and therefore only this one where the choice was private and they picked private that would have a 1, and the rest would be 0. So if that person number 7 with an ID of 7, if the option was beach and they picked the beach, that variable would be equal to 1. And if the option was peer but they didn't pick it, that would be 0. And if the option was private but they didn't pick it, that would be a 0. And that's how the dependent variable is defined. Now, the other independent variables that we have here is Q. Q is the catch rate for available alternatives. So notice that we would have them all listed, regardless of whether or not the person picked that option right here. And then we would also have a dummy variable for beach, whether or not the person picked a beach here, and then whether or not the person picked peer, that one would be the reference category, which we would miss. And then we would also have y beach and y peer. That would be the multiplication of the dummy variable for beach times income and dummy variable for peer times income. So these are additional variables that we will use. And the other variable that we would use here is price. Price is the price of the option that they of the different alternatives that people face. And these will be the different prices that they faced before they made their choice. So we would also assume that this price is the random variable. So I've defined here the y list would be D. That's our dependent variable. X list, I have here several of them. And the random variable would be a P. Now you also need to define the ID variable. And if there are any groups in there, you could also identify them. But I don't have any groups. It's only my ID variable. So I would use this, again, I would put an ID there. So we can describe and summarize. So you can see this is the ID number and the independent variables that we would use. Now, notice here that again we have the ID, the summary of that makes no sense. But again, here we have a 0.333 because in this case we have 3 alternatives. So this would be equal to 1 only in one of the 3 cases, and that's why we have 0.33. And same thing for whether or not they picked beach or private, same thing. Okay, so the way to estimate the mixed logit model on the random parameter models is you use the command mix logit. You put the dependent variable here, you put the independent variable here, then you can put the group if you have any groups. If you don't have, then just put the ID variable. Then you put the ID variable for you, that could be anything you want it to be, and then you have to give it random, which is your random variable. And in my case, this $rand is my variable P. So price would be the random variable. So you put here your random variable, whatever you want that to be. And here are the results from the mixed logit model that I have. And the way to interpret this is that if the price of an option increases, then that option is less likely to be selected. This one is a significant coefficient, which means that there is a heterogeneity in the data and people have different effects of price on their options. And you can take a look at the handout for more information on how to interpret these choices. Okay, so this was a video about how to do the multinomial Probit and Logit models, the conditional Logit model, and the mixed Logit model in Stata. Thanks for watching.